Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're examining groundbreaking machine learning breakthroughs from computer science machine learning research, published on August 24, 2025. We'll dive into 44 revolutionary papers that are building tomorrow's intelligent technologies, transforming everything from healthcare AI to privacy-preserving systems. These discoveries represent the theoretical foundations that will shape our AI-powered future. Picture this scenario. You're lying in a hospital bed, connected to monitors tracking every heartbeat and breath. The AI system helping doctors predict your intensive care stay doesn't just analyze your medical history in isolation. Instead, it considers patterns from thousands of other patients with similar conditions, weaving together both your personal medical journey and the collective wisdom gleaned from countless others who've walked similar paths. This isn't science fiction. It's happening right now in hospitals around the world. The future of healthcare intelligence has arrived, revolutionizing how medical AI systems make critical treatment decisions. Today's collection represents far more than academic exercises. These are real-world solutions addressing humanity's most pressing challenges. The 44 papers from computer science machine learning are transforming healthcare, cybersecurity, and countless other domains. This research goes beyond making computers smarter. It's about understanding the fundamental nature of intelligence itself. These discoveries bridge computer science with psychology, neuroscience, mathematics, and philosophy, creating building blocks for tomorrow's revolutionary applications where theory meets practical implementation. Computer science machine learning, known as CSLG among researchers, represents the theoretical heart of the AI ecosystem. Think of machine learning research as a vast ecosystem, much like a thriving rainforest where different species occupy specialized niches but constantly interact and influence each other. This field has exploded due to three converging forces: unprecedented amounts of data, exponential growth in computational power, and increasingly sophisticated algorithms. But this goes beyond making computers smarter. Researchers are fundamentally trying to understand the nature of learning itself, making this the most interdisciplinary field in modern science. Our first major research theme focuses on building robust and secure AI systems, what we call AI with armor. Think of it like designing cars that don't just run well on perfect roads in ideal weather, but can handle potholes, storms, and even deliberate attempts to cause accidents. As AI systems become more powerful and widespread, they also become attractive targets for attack. The research we'll explore reveals vulnerabilities in medical AI systems that could literally be matters of life and death, while presenting innovative frameworks for assessing and mitigating these risks. Security has become as fundamental as functionality in modern AI development. The second theme revolves around smart resource management, creating AI systems that can adjust their thinking budget based on available computational resources. Imagine hiring a consultant who could adapt their analysis depth based on how much time and money you have available, spending more effort on complex problems while quickly resolving simpler ones. That's exactly what researchers are achieving with new approaches to AI reasoning that operate within specified computational budgets. This breakthrough is democratizing sophisticated AI capabilities, making advanced reasoning accessible even in resource-constrained environments, like mobile devices and edge computing scenarios. Our third theme addresses privacy-preserving collaboration, an increasingly critical challenge as AI systems handle more sensitive data. Picture trying to solve a jigsaw puzzle collaboratively with friends, but each person can only share the shape of their pieces, not the actual picture on them. That's similar to what researchers are achieving with federated learning systems that allow organizations to collaborate on AI development while keeping their data completely private. This approach is particularly crucial for healthcare applications, where patient privacy is paramount, and in industrial settings where companies need to collaborate while protecting trade secrets through mathematical guarantees for data protection. Let me share the most exciting discoveries from this research collection, each representing a significant leap forward in our capabilities. First, scientists discovered that when large language models exhibit assertive behavior, this can be mechanistically decomposed into emotional and logical pathways mirroring human psychology. Second, researchers found critical vulnerabilities in medical AI systems using multiple data types, where attacks can reduce accuracy by 27%. Third, BudgetThinker enables resource-adaptive reasoning within computational constraints. Fourth, privacy-preserving collaboration frameworks use zero-knowledge proofs for secure data sharing. Fifth, optimal attention mechanisms have been identified for different graph scales. These breakthroughs represent fundamental advances in AI safety, efficiency, and capability. Today's featured research comes from Z and colleagues on S²G-Net, revolutionizing how we predict patient ICU stay duration. This work exemplifies innovative thinking in modern AI research by tackling a critical clinical challenge, predicting how long patients will need intensive care. The problem requires understanding both temporal patterns, how a patient's condition changes over time, and relational patterns, similarities between patients with comparable conditions, treatments, or demographics. Traditional approaches handle these aspects separately, but S²G-Net seamlessly integrates both perspectives. This breakthrough is critical for hospital resource management, staffing decisions, and patient care planning, moving beyond individual patient analysis to leverage population-level medical wisdom. The S²G-Net architecture consists of two interconnected pathways working together like a well-coordinated medical team. The temporal pathway uses Mamba state space models for efficient sequence processing, tracking a patient's journey through the ICU while maintaining computational efficiency even for extended stays. The graph pathway leverages an optimized graph GPS backbone, integrating multiple patient similarity graphs constructed from three distinct feature types: diagnostic features capturing medical conditions and procedures, administrative features including demographics and hospital logistics, and semantic features extracted from clinical notes using natural language processing. Information flows seamlessly between pathways, enabling the system to think about individual patient trajectories and population patterns simultaneously. The research team validated their approach using the MIMIC-4 dataset, one of the largest publicly available critical care databases. Results were impressive. S²G-Net consistently outperformed pure sequence models, pure graph models, and simpler hybrid approaches. What sets this work apart is its interpretability through attention mechanisms that can be visualized to understand which time points and patient relationships influence specific predictions. This transparency is crucial for clinical adoption, as healthcare providers need to understand and trust AI reasoning before relying on predictions for patient care decisions. The architecture demonstrates a principled approach applicable to financial markets, social media analysis, and any domain where temporal dynamics and entity relationships matter simultaneously. Looking toward the future, machine learning research is evolving like a river, constantly branching into new tributaries, while the main current grows stronger. One promising direction involves mechanistic interpretability, developing AI systems that can explain their own thinking processes. We're moving beyond black box AI toward transparent systems that can articulate their reasoning and identify their limitations. Another frontier involves continuous learning throughout operational lifetime, creating AI that adapts from new experiences rather than being trained once and deployed. The integration with quantum computing may yield hybrid classical quantum system, solving currently impossible problems. Perhaps most importantly, the field is developing greater focus on AI safety, fairness, and beneficial outcomes, ensuring AI systems remain aligned with human values while becoming more capable and autonomous. As we conclude today's exploration of cutting-edge machine learning research, it's clear we're witnessing a field in profound transformation. These advances represent more than technical breakthroughs. They're glimpses into a future where AI systems are more capable, trustworthy, and beneficial to humanity. From medical AI helping doctors make better treatment decisions while maintaining patient privacy, to reasoning systems adjusting computational intensity based on available resources, to security frameworks protecting against sophisticated attacks, these discoveries lay groundwork for AI that's not just more powerful, but more responsible and reliable. The researchers behind these discoveries tackle computer science's most challenging problems, often requiring years of dedicated interdisciplinary collaboration, driven by a shared vision of AI enhancing human capabilities while respecting our values. This content demonstrates the sophisticated AI synthesis process behind modern research communication. AI synthesis was performed using Claude Sonnet 4 from the 2025 0514 release, with TTS synthesis powered by Deepgram technology and image generation through OpenAI systems. Human expert review ensures accuracy of the synthesized content. Though some oversights may exist, all references are provided for verification. This collaborative approach between AI systems and human expertise represents the future of research communication, making complex scientific discoveries accessible to broader audiences while maintaining technical accuracy and scholarly rigor. Thank you for joining us on AI Frontiers, your gateway to cutting-edge artificial intelligence research. Subscribe for weekly deep dives into breakthrough papers, expert analysis of emerging AI trends, and connection with our community of researchers and enthusiasts. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive preprintserver.org.